Okay, so a bunch of us were discussing this prior to the composability meeting, and we're dragging this topic in. But for those of you who weren't at the previous discussion, I'm just going to sort of briefly, like, give the background and what we are talking about. So there are a few ways to sort of also Driss and Co. Like, feel free to like butt in and correct me if I'm misrepresenting the things. But essentially, the way that I think about what exactly the problem we're talking about here is there's a few ways to look at it. What's the problem? So here's one problem. Suppose you use flex attention, but not compile on your model. So you want to compile your flex attention because flex attention is very slow and has different numerics in eager, but you're not torch compiling your entire model. You just want to use it in eager. And you want to use selective activation checkpointing. So selective activation checkpointing uses a torch dispatch, tracer to sort of keep track at a fine-grained level what forward computation you might need to do in order to recompute something in question. So the problem is that this doesn't work. Torch Titan has been complaining about this for quite some while. And I want to explain why this does not work. So the reason this does not work has to do with SAC. So when you're doing activation checkpointing, eventually it comes a point in time when you need to recompute some things that you want to do. In traditional non-selective activation checkpointing, just regular AC, the way we do this is just the user gives us a callable that is the forward thing they're going to recompute. And then we just go ahead and run that callable as is. No muss, no fuss. Flex attention compile works fine with that. Yes, NYC.
So I guess there's like two different versions of AC. So like AC2 is the one that uses torch dispatch to do the tracing. AC1 SAC still does the replay with the callable, but it uses the torch dispatch mode only for the caching layer. It doesn't actually use torch dispatch mode for the tracking of the operations itself.
Thank you for the correction. But AC1 without the SAC doesn't use the torch dispatch mode at all.
Correct.
Yeah.
Yes.
So, uh, sorry, not the track. So in SAC, the reason why I need a torch dispatch is for the caching, and the way the caching works. Jeffrey, can you complete this sentence for me?
The way the caching works is it intercepts the operator outputs or operator execution, and it matches like well the user will have a policy function that takes in like torch dispatch will give you like func, args, quarks, and stuff. So we will pass that to the user's policy function, and the user policy function will return us technical policy, like either save or compute. And if it's saved, we'll like store this thing in a list or something that we can later use to well, then we'll have two essentially torch dispatch modes. The second torch dispatch mode will look at the list that we stash, and if we see the same op, it'll call the policy function again, second time around. And if it sees the same, if it sees it's supposed to be saved, it'll check the list and return that instead of recomputing the function.
Yes. So the sort of distinction here, which I think actually doesn't matter too much, is we do not literally save the computation graph. But you are still like intercepting individual calls and then making decisions about whether or not to actually run them or use the things that are saved. Okay? So now here's the compositionality problem. The compositionality problem is if you torch compile something, like you literally put the torch compile decorator on it, you can no longer torch dispatch on it. Like the torch compile region is just this sort of black hole, and you never get called on the torch dispatch handler in this case. So SAC breaks. Do we have any questions about this problem?
Um, it is it a bit more subtle than that? That it can get cold, but you don't have access to the same eager ops, and so you can't make the decision you want to make.
Yes. So problem one, the torch dispatch mode is never called. But problem two, even if the torch dispatch mode was called, you get a big single lump of the entire compiled thing, not the individual ops.
Right.
And one thing I want to say is problem 2 is not always a problem, because sometimes, you know, that's fine. You don't care. Like you just needed to be able to intercept anything at all. You didn't need the intermediate pieces. Whether or not this is true or not depends on your torch dispatch mode. So this is the like main problem. Yes, Francisco.
Damn it. Hey, can you hear me?
Yes, we can hear you now.
Yeah. So this is the current implementation we have for SAC, right? Which I'm kind of guilty of as well. But would there be other implementations that would not use torch dispatch and then not fall into this problem that we could leverage and that could be more compile friendly?
Right. So in fact, there are. Right. So well, okay. So AC doesn't use torch dispatch, right? But it's very inflexible because you have to run the entire freaking callable all over again. SAC and AC2 use torch dispatch. You know, in different ways, but they're both using torch dispatch. Graph-based AC doesn't, but this is cheating because we're just saying, oh, you somehow captured your graph, and so you do have the graph. You don't have to torch dispatch because you got the graph some other way. Francisco, I'm not really aware of any other approaches. Like, it's just not easy to do AC in eager mode.
Okay, so then everything's gonna pass.
Manual AC as well.
Yeah, so basically it has to pass through torch dispatch in the current way we do things, right?
I haven't thought about this too much, but like I think Simon brought this up as an idea potentially. It's like using torch function method instead of dispatch mode to do the caching.
Which doesn't help here, by the way, because we don't have a torch function on torch compile either. There was a question, but I don't know if it's still there. Okay. So the SAC thing is the one we care about the most, but the more general instantiation of this problem is how does torch dispatch interact with torch compile, right? Like, we have some yeah, it's kind of like, you know, this general problem is like difficult to solve, but like that's at the heart of the situation here. But there's another generic formulation of this problem, which is essentially, how can you torch compile kernels and then use them like they are normal eager kernels, right? Because in some sense, right, like normal PyTorch kernels don't have this problem because they're registered with the dispatcher and everything like that, right? Like, why can't I just have torch compile kernels look like normal eager mode kernels, and then wouldn't SAC work in that case? And what we will find is that flex attention makes this more difficult.
Why? Do you have a bit of details on that?
So the reason it makes it more difficult is because of the so one, tons and tons of arguments, and two, the closures, like the score mod and stuff. NYC.
Another alternative to like the AC list, like another way to do AC is with makeFX. That doesn't use torch dispatch, but like I guess makeFX kind of. But like
it's basically torch dispatch.
But can you do like kind of like a wrap, FX that wrap layer that like wraps the compile artifact and inserts a call function to the graph?
Yeah. All right. So I think this is a great segue into like talking about approaches. Yes, Albin.
I had a question.
Oh, yeah,
Follow up about closures. Is it flex attention itself, or is it just any higher order op that takes in like another function that's hard?
So
specific-
you
the
can
closure reference?
generalize to any higher order op, but flex, you do want to focus on things like flex or scan, things that like must be compiled for good performance, like torch.con, torch.wal. I don't really care, right? It's not a
I
huge
see.
deal if you don't compile them.
And do you have a quick sense add on like the discussion we're having with Angela on pass a pi object, promise me there is no tensor or simit in there? Would that help that problem?
Yeah, so custom pi, and in fact, I think Driss is relying on this in one of the implementations.
Okay.
All right, so let's talk about approaches. Okay, so approach one that we've been discussing. Okay, so first off, we're going to assume that we need to work with SAC, right? This is a bad assumption because, as I said, if you graph mode or you like solve it some other way, like that solves the problem. But let's say that we just wanted to work with SAC out of the box. So, all right, I'm going to call this approach 0. So approach 0 is manually create a custom op and have it call directly into flex attention, compiled flex attention forward and backward. And Driss, now I wanna like put it to you to just show us how horrible this is in reality.
Yeah, I mean, I can just show you a code pointer, I guess. Ignore. Actually, should I be showing this? I can show this one. I actually don't have. This is an old version, and my code got lost. But essentially, this is like using AOTI and precompile to generate an artifact. And then we need to, sorry, there's a lot of code here.
So let's start at the like top level function, the custom op registration.
Yeah, okay. So this is what we ideally would want to do, I think, in a like precompiled world. Which is we register a custom op for flex attention. Its implementation roughly spoofs flex attention's implementation. Some already like new features required is like dictionaries are not very custom oppable, so I'm using an opaque type. Block mask is the composition of tensors and tuples of ints and callables that may like need closure objects. So this has to be an opaque type. Um, and we have to do some processing to get them like into this artifact form. Again,
Let
this
me
is
ask a question real quick. So
yeah.
so block mask has closures in it, right?
So what is it? I mean, let's be more concrete about closures. Block mask contains a callable, and that callable may reference global tensors or tensors in local scope where the callable is defined, and that's what we consider a closure. And a lot of like the magic or like why we use Dynamo and why this needs to be a hop in a lot of senses, because we utilize speculate subgraph to grab that closure and make it an honest to goodness op, or sorry, an honest to goodness input to the actual higher order op implementation. Let's find this. So if we go to the hop, we have this like list of other buffers, one for score mods, one for mask mods. There's two callables as a part of flex attention, and we need Dynamo to like grab these closure tensors and populate this tuple. Um, and I like honestly don't know how this would work with a custom op.
Right.
Or like
so
yeah.
so if in the super manual universe where we're going to specialize on a score mod and we specialize on a mask mod. So Driss, you're a little ahead of me. So I want to start with like something super basic.
Yeah, go ahead.
Right. What you would just do is you would write the op, and you would, because you have specialized to a specific score mod, you just have your op take those extra other things directly as inputs. And it would look ugly, and the user would have to modify their code so that they can't just pass in a closure, and they have to like manually feed in the arguments. But this clearly would work, right?
Um, yeah, I think it would work.
So this is the like sort of basis thing, right? So we're just showing that like yes, in principle you can write a custom op signature, but because of the callables, you actually have to ugly it up. You basically have to lift all the free variables into explicit arguments yourself and then call it directly yourself. Questions from the room?
Just to be clear, the uglying it up would be done automatically during torch compile. The only place where the end user would see it is in their torch dispatch handler, where they would see these extra arguments instead of seeing the function.
Right. So we're
Okay.
first imagining a universe where there's no torch compile at all, because that's like the sort of simplest runtime situation to be in. And I'm just like trying to convey that like it's very like you actually kind of do want Dynamo to run.
Yeah. Yeah, the Dynamo handles the ugliness for us.
Yeah.
Is a good way to
So
put it.
does anyone want to argue that we shouldn't run Dynamo? Because otherwise I'm going to table approach 0 and be like, we're not going to do this because it's too ugly. Like it's actually really helpful to have Dynamo involved.
I
Oh,
I think I have a high tolerance for the ugliness for custom app.
Okay.
I have
Show off
seen
objects.
yes, I have seen TBE. I have seen their like 2000 lines of rewrite just to make a custom app. I think it's terrible, but it's simple and it works. And like by introducing Dynamo, yeah, you have a bunch of other problems that you need to solve. So I don't want to completely way off this like just because of it's ugly.
NYC.
So this,
so there's don't run Dynamo, then there's run Dynamo, but then for run Dynamo, there's run Dynamo
Well,
above the custom op.
we're still in the no Dynamo space, so let's live here for a little bit. Can you?
So my question would be, if you make a custom op with score mod, mask mod all being inputs, in the model, if you have multiple instances of master mod or score mod, do you call different instances
Yeah,
of
you have to call
this?
different functions, one for each specialization.
Okay. I think it all depends on how much do we care about eager. If we just want workarounds, I think this is acceptable, and we just all-in compiler. But if not, I think this is not very elegant.
As a user, I would not want to use this. That's another way I would say it.
Yeah. So one problem is that like this is actually I don't think if a user has run into this problem, I don't think we can actually tell them to do this. Like it's actually I think
Pretty
it's like
good.
kind of difficult. Like we would actually have to write some code to help them. And yeah, so like I like just I think my representation of where you are is like it's gonna like oh, this is so awful. I don't want to write this code to help people do this.
I mean, yeah, I think it's do. I don't know. Maybe I'm fine with like maybe writing it. I don't want to maintain the code that does this. I think it's like another way to say it. And um, I really think I think it like the flexibleness of flex attention is why people like using it. And I think this is just like, hey, you don't get it. Like we're throwing away all the good parts. Uh, take it. Which like again, for some users, maybe it's worth it, especially if you're like really you can't train your model because you're running out of memory and you need SAC. But
So
I
I
would
only mentioned that sometimes people just take the chardon from Flex that's generated and just paste it in.
I love that for what it's worth. Like I recommend that to people. For the flash attention integration that I'm working on, like I've completely designed it where you do not need flex attention. Like you do not need the front end call to flex attention. You can just go to flash attention, and I will show people how to do this. But it is such a nicer experience to use flex attention to generate these callables and these score mods that I still think we provide enough value. So, but this is like saying like throw away, I think, the nice value we add, and we're doing the copy and paste flow like worse, and we're trying to make it generic, and it's, I don't know, the wrong tool for the wrong job.
Okay. So I think I'm happy to take approach 0 as we can tell people how to do it, and we are not going to do it, even if you are very important. And like I'm okay with this decision. All right, so let's go to the next approach. All right, so Brian, you wanted to which next part of the design stage did you want to roll to?
So we were saying no dynamo bad, dynamo good, but we need a custom op. And one option is you run dynamo above the custom op. Another option is you run dynamo below the custom op. And I think this also has problems, but it does, like the problem that it does solve is suppose you run flex attention 3 times at 3 different block masks, then we are generating 3 different kernels. And so either the user needs to manually call those 3 different kernels in the right places in their code, or we have like one custom op that knows to do the dispatch for those 3 kernels. And then Dynamo running inside the custom op is like one way to get that.
Yes. So so on the dispatch problem, Driss and James, did you have a specific angle? Like, is this something that we didn't have an opinion on, or did you have an opinion on this? So you have like 3 instantiations of flex attention. Who is like making the call about which one?
We can handle either case, especially in the
have an opinion
precompile
on
world.
this?
I'm having trouble imagining a world where the Dynamo invocation is above the custom op, where we wouldn't have to change a lot of compile to be able to handle this, right? Like if Dynamo was above the custom op, then the custom op would need to be like, we would need a special compiler pass to, like, we need to do the inductor thing, the generalized inductor thing that we talked about, where
Okay, so
inductor
actually,
generates
Brian,
that, right?
I'm gonna kibosh this, and let's just talk about the generalized inductor thing. Okay, so the generalized inductor thing is this. Okay, so we're like, hey, we need a custom op, or at least we need something that has a torch dispatch handler. It doesn't have to be a custom op; it could be a higher order op, but we need something that will call into torch dispatch if a torch dispatch mode is on, aka for activation checkpointing. We're going to ignore Albin's thing about like, oh, what if you need to see on the inside? We're just going to assume that the torch dispatch mode is okay with seeing just a big opaque blob. Okay? So now if we think about the runtime structure of what a torch compile thing is, and we're using most of it as is, then the first logical point to put in the torch dispatch call is we have to get past Dynamo bytecode, we have to get past AOT autograd function, and we want to put something in the forward of the autograd function, and we want to put something in the backward of the autograd function. Well, we don't need the one in the backward, so we can just focus on the forward one for SAC. Right? So the pitch is, let's introduce a new higher order op. Let me share my screen again. Introduce a new hop inductor compiled code and apply it inside the apply it around the callable that compile fx inner generates, aka inside the autograd function. So this is guaranteed to have a relatively simple signature of tensors and maybe ints, I guess, if dynamic shapes are involved, and produces a bunch of tensors. It's complete like garbage in the sense of like what is it? Oh, who knows, right? It's just this big blob, but it will show up for SAC. And if you have some way of telling that this is a flex intention compiled fx inner, then it will still be possible to do SAC policies on it. Okay, so James, I think there was some like technical reasons why you didn't like to do this for short term. I don't know if you felt better about it mid long term.
I don't think there's a big reason why I think it's bad. Like other than I having not done this before, I don't think it's that like I think it's fine to do in any timeline. Like I don't know how long this takes, but like I think we did discuss CPU overhead and stuff with this approach.
Right. So if you put the inductor compiled region in a hop, there's no way around testing if torch dispatch is on or not. So this will add some overhead. Although our overhead is kind of bad already. So what's another microsecond between friends? It is technically BC breaking if you are like randomly running torch dispatch infer modes over compile regions. But I don't think like the only infer modes are like debug mode. And debug mode is like fine with this. I think this is like in general it's a pretty good solution. James, you also had a technical problem, which is when you want to precompile, it's annoying to get the precompile thing to this. Is that right?
I think that if you were to do this, basically what we would do is we'd introduce a setting that makes it so that when you run compile, regular torch compile, it wraps the forward and the backward in this hop or like whatever you want, forward or backward in this hop, right? And theoretically, this hop should already be serializable, right? Like, I don't see a reason why it's not. And you would just serialize the whole thing. Like you would save the whole object, the forward, like the whole autograd generated object. And you would just precompile that whole thing, AOT precompile like the entire thing you torch compiled and be able to load and save that, and it should be okay. I think the thing you would need to figure out is to make sure that the hop that this inductor compiled code hop that you've generated is actually like serializable, and the load when you load it, it's fine. But I don't think that that's like it doesn't seem hard, right? It seems fine. It seems like it's work to make sure like you have to like redo the hop or something, but like it's reinstantiate the hop on load, but it should be fine.
Driss, did you not like this plan for some reason?
No, I think this is the plan I liked. I feel like this could also apply to more than just Flex, which is why I liked it.
This works for any torch dispatch thing. You also technically don't have to do a hop, I guess. You can just have a torch dispatch or just have a conditional.
Wait, is it a hop? Isn't it a... I'm a little confused because if it's a hop, isn't like flex attention a hop already? Like what's the point in wrapping a hop in another hop? Isn't it supposed to be a custom hop?
Got evaporated by the compile process. There is no flex attention anymore.
Oh, because it's decomposed, right? Okay, okay.
Well, I mean, and you compiled it, and you know all that stuff, right?
Yeah. Okay, I get it. This is like an eager hop almost. Yeah, okay, that makes sense.
Actually, I don't know why we were so resistant to this.
It's like a black box inside where like you've basically hidden anything that can happen inside of this hop, right?
Well,
was that a problem?
Compiled stuff.
Like as in like you don't really know the signature of this custom hop, right?
Yeah, you don't know what the signature is. You don't know what actually the stuff in it is unless you like have Inductor generate enough info so you can like figure it out. Right. So
you don't know what it returns.
So you need an answer for this, even if it's as simple as could be as simple as saving the FX graph that was passed to compile FX inner.
My theory on that was the option that lets you wrap it into a custom hop lets you specify what the name of the custom hop you want to wrap it in is, and then that would be the thing that you SAC.
No, because like you don't have a way of guaranteeing that the flex attention region is the only thing in your torch compile region.
Oh.
Right, I agree that you could like, bubble it into the hop among other things. But like in full generality, you can't assume that.
Oh, so what you want to be able to do, but that's confusing, right? Because what you want to be able to do.
I don't blame you for trying to like be like, but let's just worry about flex attention. But I'm just saying.
Oh no, what I mean is like I thought the problem is this, right? You want to be able to SAC torch compiled code. So then the solution is you make a custom op around around the compiled code that has a torch dispatch. I think it is more confusing to say you want to SAC parts of compiled code rather than the entire compiled code that you want to compile.
No, you only ever SAC the entire. Well, I mean, you can't.
So then if it's
can't subdivide it because like there's no way to run only part.
Right. So then by that logic, isn't it enough to just be able to name the custom op because that's always going to be the entire compiled region?
Okay, but the name is on torch compile. It's not on the custom op inside. It's not on the like flex attention call inside. Right? Because what exactly you're compiling is demarcated by the torch compile.
Why is what I'm saying not making sense to me? Basically, it's you specify a string or a key of some sort, and this key is metadata about that's inside the custom op, so that when you execute the custom op, it has a name, and then SAC sees that.
We can do that. We can put that on the inductor compile code op. I'm just saying the only place to put this string logically is on the torch compile itself.
Yeah, so you can't put it as a global option. It would have to be a option in the torch compile list. Yeah.
Sherlock.
Yeah, I want to draw similarity between this approach and a pre-existing op that we use in the PD2 inference stack that to handle AOT inductor compiled artifacts. So the hub is called AOTI call delegate, which has a very similar concept here. So number one, it is serializable. So essentially it takes in a few things. So first of all, it takes in pre-compiled artifacts, right? So in this case, like you have a pre-compiled artifact to back the execution of this hop. So number two, it can optionally takes in reference eager graph implementations. So essentially, like if you provide a flex, like the original input to the compile inner FX, like that's your eager reference function body. Number three, about the arbitrary number of inputs kind of thing, like in the call delegate hops, it is modeled as a simple just a list of vector and list of cement. This is the signature used by AOT inductor. You just have to like they are positionally indexed. Like yeah.
Yeah, sounds very similar. I agree. Jess?
My mental model of hops basically are like ways to smuggle subgraphs through in like the full compile stack. At this level though, like I mean this is just like a pedantic question. Is it a hop or is it a custom op? And is there like a meaningful difference?
So I changed my mind. So we were talking about custom ops, but I was thinking about this. I don't want this to be a custom op. Why should it be a custom op?
Right, like the main thing we want. Oh, okay.
So hops will work with AC, I hope. Oh, I don't know actually. Jeffrey, do hops work with AC?
I think you need a special thing, but it's like 2 lines, should be fine.
Is it fair to say the main thing we need is just like a registration in the dispatcher that something can interpose on?
Yeah, like the AC just needs to know how to like, operate on these hops, essentially.
I think the challenge here might be that you will have to put the custom function at the right place if you have a custom function from this compiled region. So that AC can find the right information.
What do you mean by custom function? You mean the autograd function?
Yes, the autograd custom function. Yes, the autograd function.
The autograd function works it just wraps around the forward calls into inductor compile code, and the backward calls into inductor compile code. And I'm concretely proposing we don't have anything wrapping around the AOT autograd function. This should work, right? Because SAC works with custom autograd functions.
But if you want actually this to be a custom op, you need the custom function to be registered at the autograd
there's
key.
Two versions of this. One where it's a custom op and one where it's a hop, and I don't want to be. I don't want it to be a custom op anymore.
Okay. Well, what I'm gonna say then is just if you want features that use torch dispatch, like SAC to work, you will need the autograd to be registered at the autograd key and the kernel in the backend key. And to do that, you will need a custom op and properly separate a custom function from the forward call, which I don't think we do today.
Is this specifically about ops, or does it also apply to hops?
I don't know how the torch dispatch handling for a hop happens, so I can't answer.
Okay, let's reason through this step by step. So, SAC's torch dispatch handler only needs to see, well, it's a torch dispatch handler, so it never sees autograd, right? It only ever gets called after autograd has been applied.
Correct.
So it doesn't matter if the autograd function itself is an op or a hop.
As long as this is registered to the dispatcher, correct.
Yes. So mainly the thing is that you won't get called on your torch dispatch with a hop. Instead, you have to do the other dispatch where it goes to the handlers on the hop itself. But I basically have decided I don't want custom ops because I don't want a big pile of like anonymously named custom ops. Sounds bad. Like,
and does the hop handler require that same separation of concern of like autograd needs to run, then it's going to trigger the handler, then it's going to call the kernel?
So Albin, so another problem that I have here is that even if I wanted to have a custom op that had an autograd registration, this would just be its own op. Like it would be you know how like we have users where they define like foo and then it calls foo forward and foo backward and there's like 3 ops, right? Like I think everything generated by torch compile would also have the same pattern because the foo forward function has tons of extra outputs that are the things saved for backwards that aren't outputs for the autograd function.
Well, but the foo is not a custom op, but otherwise, yes, I agree.
No. I'm saying people have foo via custom op with an autograd registration. Like this is very common.
In the context of compile, I think your Python wrapper can remove the extra arguments without it being an op, but I think it's a detail. I agree.
Yeah, this just sounds complicated for no reason because I don't need it to solve the SAC problem. Like I agree there's some aesthetic you're going for here and it just doesn't seem necessary to me.
Well, I'm still confused how the hop interacts with SAC AC2.
So concretely, the hop basically is like any other op in AC actually. So some hops need special handling, but AC will just be like, well, this is just like another operator.
I sent you a PR out of me adding flex to SAC, and it really is 2 lines. Yeah.
Yeah, let's pop this.
But I don't know if this is special because like hops are typically like singletons. And so you just like register the singleton with I guess the interesting line is in flex attention.py. You'll see that, yeah, those two, you just redirect it.
Yeah, this is great. This is what I expect you need for the inductor compile code.
And you might need some like a little extra fluff in utils checkpoint to like check names or something, or like check one piece of extra info on like the name you specified.
Alvin, does this make sense?
Nope.
No. Do you want to keep pushing on it, or shall we continue?
Do I want to keep pushing on it? Okay, I think I'm confident that AC will work without issue. Yes, I agree with that.
Well, no.
My
you
concern
mean
is specifically
AC
SAC.
always works. Do you mean SAC?
Yes. Yes, SAC and AC2 was my concern.
Okay, so let's recap how SAC works again. Right? So the way SAC works is we install a torch dispatch mode when we run forwards. And every time it gets called, it figures out if you are going to save or recompute. And if we're going to recompute, right, it goes ahead and saves all the stuff it needs so that it can trigger. Is that true? No. Sorry, other way around. If it says, oh, I'm going to save, then it just saves some output and enough info so that we need a quality test to work on these higher order op, by the way. I think. I don't know how safe SAC is in this respect, Jeffrey.
What do you mean by quality check? Like
well,
if
so
function is
like
the-
what like do you actually check that the second time around you get the same like sequence of functions?
you check that it's the same function. Yes.
Yeah. Okay. So equality tests need to work, but essentially, you are like, oh, if I want to save, then I'm going to go ahead and save the output, and then the next time around when I see the same func call again, I'm going to just give you back the saved result. Does this make sense?
So yes, these make sense. But I don't see how that
instead of func
interacts.
being a custom op, it will be one of these inductor compile code hops. And assuming you can test equality on it correctly, like you just do it the same way. Because in effect it is just a custom op, right? I'm using the hop in sort of like I didn't technically need a hop, but I'm just doing it that way so I don't have to register lots of functions.
Okay. So I guess my only concern then is I can see these having a slightly different behavior with respect to AutoGrad compared to a custom op, where in the AutoGrad world, the output you see here doesn't have AutoGrad metadata populated yet, and here it might already be done, or things like that. But what I hear is this doesn't really matter, and at the end of the day, we save these things and we're okay.
Well, not only does it not matter for SAC, but also the point in time when I dispatch to inductor compiled code will be on the inside of the AutoGrad function. So it's also not going to be set anyway either.
Okay. I think that part answers my question then. Yes. Okay. So you do run the custom AutoGrad function first, then you dispatch to the torch dispatch handler.
Yes.
And from there, you actually do that. So yes, so you do have the appropriate layering, even though it's completely independent of the dispatcher one.
Yes.
Okay. Thank you.
NYC?
I was going to say the same thing, that we get this invariant that our fancy new hop is always called from within an AutoGrad function. And maybe we should assert that that's always true.
Okay. I don't even want to talk about the other options. Like, we should just do this, right?
I think maybe the only thing to call out is that if there is a future where we want to be able to slice up the compiled region into like recompute and not, then we will need to change things. But this does seem like a very reasonable first thing to do, ignoring that second thing.
I agree. One way that you could do this slicing is simply, if you chop things up before you call AOT AutoGrad, you automatically get multiple inductor compile code regions. Simon.
I might have missed it, but why does the new hop always need to be called within an autograd function?
It doesn't. But
Well,
the ops aren't differentiable, so you had better not try to backward through them.
But that's just up to the tracer.
Sure. Okay, so James, James, are you gonna try to do this? I think this is pretty
Yes.
quick, actually.
It might not be quick for me, but I will try.
Okay.
I will try.
Well, let me check. Driss, do you think it's quick for you?
It's just interesting how
I don't know if the quickness has a big delta between the two of us.
Okay. Well, I have an hour after this meeting. I could see if I can do it in an hour. Does that help?
Yes, that would help.
I will try to do it in an hour in that case.
And then you can hand it off
And then I'll
for
hand
us
it,
for me to land or anything. It's fine. Yeah. It doesn't sound too bad. I've just never done it before, but it seems fine. You wouldn't want this on by default, right?
No, I want it on by default. Yeah. Well, we'll config it, I guess, because that will make it less likely to get bounced. But I do want it on by default.
Well,
if it's on by
it feels
default,
like. Sorry.
I'm trying to understand what the inductor, where the outputs and stuff. Do we want it on by default? What problems do I have with it being on by default? Does it make debuggability harder because it's all inside of a black box now with the call stack?
No.
Should be okay.
Alvin?
I like the idea of making it on by default, as it is definitely in the direction of like we want inductor generated code to behave more and more like regular ops we have otherwise. So that regular instrumentation that we have through torch dispatch or profiler or other things, catch things from
Actually,
inductor one
Alvin,
way.
I have a question for you. Can you think of any use case where having the IoT autograd custom function be in an op, that being useful? I actually can't think of any.
Well, you could remove then the custom profiler logic there because you have the dispatcher logic there.
Okay. NYC?
Last thing I was going to add is because we've been talking a bunch about different backends like AOT eager versus inductor, you probably want AOT eager to still generate the hop, so it works with SAC if you're like playing around with AOT eager versus inductor. So maybe this hop should be generated
Actually,
in autograd instead of inductor. I'm not sure.
You don't, because everything in AOT eager is dispatchable, so it works.
Yeah, that's fair.
Yeah. Do we want it to work with, sorry, I didn't mean to interrupt people. Do we want it to work with the scooper and everything? But the scooper doesn't do exactly this, so.
But the scooper eventually calls compiled fx inner, right?
Yeah, but it's going to still be
work.
hidden in the graph, but yes. Yeah.
It'll work. Driss?
For keeping it off by default, I mean, like, if you call a matmul today in one of these regions and you had a debug mode, you would see the matmul call eventually, right? Then you wouldn't if this was on.
So the BC breakingness is if you had somehow infra torch dispatched over compiled inductor code, you would fail to see all the Trident kernels, but you would see all the like regular kernels, and maybe someone was using that for something. But yeah, we would break that when this is on. This is why it's safer to flag to start. Eileen?
Maybe this is a newbie question. Like, does it help having this as an op help by like comparing the numerics between the eager kernel and the generated Triton kernel?
Yes. So yes and no. So yes, in the sense that if you have an infra torch dispatch mode that you're using to like hash tensors, now you actually get to see the compiled region outputs. But no, in the sense that often you need to have info about the inside, and you don't get any info about the inside. Okay, shall we end early?
We have to make sure it works with all the caches and everything, but I think it should be fine because it doesn't change
as
anything.
long as it's serializable. That,
Yeah.
I'm not gonna figure that part out. James will let you figure that out.
Sure. That is something I'm good at. I can do that. So,
Well, Ed, are the mask function, they're not going to be serializable, right? In a whole bunch of cases.
By the time you get to the inductor compiled code, it's literally just a big pile of tensors.
Oh, okay.
Yeah, it's all.
Oh, you already inline that into the Triton kernel, so
yeah, Dynamo.
Okay.
Yeah,
who takes care of that?
We do, or Flex does.
Is it Dynamo or IoT Autograd? I think it's IoT Autograd that takes care of that.
No, I mean at Inductor.
Sorry,
at Inductor we have an FX graph, and then we convert that FX graph into like it's stringified into the kernel.
No, but what I mean is that we never pass a score mod into the inductor compiled code, right?
No, it's FX graphified.
Yeah, so I think it's done by Dynamo because I don't think we pass a score mod to IoT Autograd either.
It's done by Dynamo for sure.
All right, thanks everyone. I'll hurry up and do the prototype. All right, see y'all.